Hi guys, and welcome back to the channel. It's Izzy here, and today I'm going to be talking you through factorisation of linear expressions. This video is part of a series on factorisation, so we are starting with this video which covers linear expressions, and then there will be a couple of other videos covering quadratic expressions. Factorisation is the reverse of expanding brackets, which you should have seen before, and it can be used to simplify quite complicated expressions. And the way we use it is by grouping up common factors between the different terms in the expression and place them outside of the bracket at the front. So then we have our common terms, and then we have what is left over inside of the bracket. So now I'm going to give you a step-by-step of how we can go about this. The first example we're going to be looking at is one of the more simpler linear expressions out of all the examples we have today. This is 3x cubed plus 6x squared plus 18x. And the reason that this is one of the more simple ones is because it only includes one variable, which is x. The other examples we will be looking at involve multiple variables such as x, y, and z. If you are interested in factorising those expressions, please feel free to skip forward in the video. The first step that we want to be doing with this expression is checking for a numerical highest common factor. To do this, we look at the coefficients, so the numbers that are in front of the x's. In this case, it is 3, 6, and 18. The highest common factor between these three numbers is 3. That means that we can take this number and place it outside of the brackets, and we write what is left inside the brackets. So in this case, 3 divided by 3 is 1, 6 divided by 3 is 2, and 18 divided by 3 is 6. Because we know that when we expand that bracket out again, we will be multiplying each term by that 3. Because it is the opposite, we need to divide it by that 3. Step 2 of this factorisation is to find the highest common factor for the algebraic terms. So a better way of saying this would be to find the highest power of x that can be taken out. In this case, we have x cubed, x squared, and x on its own. I've written these out so that it is a bit clearer. We can see here that the highest power of x that can be taken out is x to the power of 1. And if we put this in front of the brackets, it leaves us with x squared, x, and then 6 on its own. Because x to the power of 3 divided by x is x squared divided by x is x, and x divided by x is just 1. So rather than writing 6 times 1, we would just write 6 on its own. Step 3 is to check the brackets to make sure that we haven't missed out any common factors between them. Sometimes when it comes to finding the numerical highest common factor, it's quite easy for us to miss out the largest and go for the second largest, for example. So that is important, and equally as important, and again a really nice thing about factorisation, is that we can just simply expand the brackets and check that we get our final answer and we haven't missed anything out. So here I have expanded it again, and it looked exactly like the expression that we started with. Just as a side note, these little dots mean therefore. So therefore, 3x brackets x squared plus 2x plus 6 close brackets is identical, that's what these 3 lines mean, to the expression we started with. Therefore, we have factorised successfully. Next we have example 2, which is an expression that includes 2 variables now. This is one of the more simple examples, just so that I can show you through the steps, and then there will be a video at the end of this topic with some harder questions. These steps are very similar to the question we've just done. So the first step, as always, is to look for a numeric highest common factor. In this case, the coefficients are 2 and 4, so the highest common factor is 2. I have then placed this outside of the brackets. Step 2 is where we see a difference because now we have these two variables, and for now it looks quite simple, but in other questions when there are multiple variables and it's quite complex and there are lots of terms, this method is really helpful because it prevents us from making little mistakes. In this case, I have highlighted the x's in pink and the y's in blue so that we can see the difference visually. And I've compared the x terms and I've compared the y terms. These are then being placed outside the brackets, and inside the brackets, again, I've just included what would be left over. The final couple of steps for this question would be to check our answer and make sure that we didn't leave out any common factors, and then finally to expand our answer to make sure that it is indeed correct. That brings us to the end of this video. It was just a short video in order to outline the key steps in factorisation of linear expressions. The next videos will be on quadratic expressions, and then there will be another video in this series going through some more difficult example questions. I hope that you found today's video helpful and also enjoyable, and I will see you next time.